How can there be clouds in winter when it is too cold for water to stay a vapor? First of all, clouds are never made out of water vapor. Water vapor is invisible because its molecules are too far apart to optically scatter light. Whenever you see steam, mist, fog, or clouds, you are seeing small drops of liquid water or crystals of ice breathed and, not water vapor. The water drops or ice crystals in the air are usually too small for you to see them individually, so instead you see a white or gray haze. For instance, with every breath you exhale, you are blowing out water vapor that has evaporated from your lungs. You don't usually see your breath because the vapor you exhale stays in the gas state. But when the air outside is cold enough, the water vapor you breath out quickly condenses to little drops of liquid water and you see your breath as a small cloud. Secondly, clouds are not always drops of liquid water. Clouds can also be composed of ice crystals. In fact, the same cloud can be partly composed of water drops and partly composed of ice crystals. Clouds have no problem existing in the cold of winter, because they can just exist as ice crystals. Even in the summer, some of the clouds you see are composed of ice crystals. A lot of the raindrops we experience in the summer started their existence high in the sky as snowflakes but melted before reaching us. When the water drops get high enough in the sky, they encounter colder temperatures at higher altitudes and freeze, even in the summer. Both water drops and ice crystals in a cloud are so small that they both look like white fluff from the ground. You usually can't tell the difference between a water cloud and an ice cloud just by looking at it. But there is a difference. Water drops are mostly spherical, while ice is crystalline with flat surfaces. This difference in shape means that the types of bows they create are different. Water droplets in the air create rainbows, while ice crystals create sundogs, halos, and arcs. Thirdly, water can exist as a liquid in winter, even below its freezing point, if there are no nucleation centers. Sub-freezing liquid water is called supercooled water. For liquid water to condense to a solid, it has to be cold enough and have somewhere to freeze onto. All it takes is a bit of dust or even vibrations to kick-start crystallization. But in certain situations in the atmosphere, such nucleation centers are sometimes hard to come by. As a result, the water can stay liquid below freezing temperatures. Lastly, even when the air near the ground is at freezing temperatures in the winter, there are still often layers of atmosphere higher up that are warm enough for water to stay liquid.